it's your favorite NPC, and today I'll teach you all of the essential JavaScript concepts without wasting your time. By now you know HTML defines the structure of your web page, and CSS makes it beautiful, but it's still static. And in order to change that, we can use JavaScript. JavaScript makes your website interactive and alive. Buttons that do something, forms that validate input, sliders, pop-ups, and even games. Basically, all of the cool stuff we love about modern websites. So let's get started, guys. To get started using JavaScript, we should first get a code editor, and I'm going to use VS Code in this course. Of course, you can use whatever you want, but if you really want to use JavaScript, I definitely recommend you to use VS Code. You can just go to the page, download for Windows. We are going to wait until the installation has been finished. Once done, let's press this .exe file. We're going to press I accept the agreement. Next, this is fine. Next, install. And let's wait for the installation to finish. Once done, you can press finish, and this should automatically open up VS Code. It should then look like this. If it does not open up automatically, you can also enter Visual Studio Code within your search bar and just open it here. Now that we've done this, we can open a new folder or create a new folder on our desktop. So right-click, New, Folder, and this is, for example, JavaScript Course. Of course, the name is up to you, but now we can take this folder and drag it right here to the left, and this will open Visual Studio Code within this folder. JavaScript has been created for web development. Therefore, you use JavaScript to manipulate the elements on your HTML page, for example, and react to user input. In order to use JavaScript properly, we should therefore create an index.html page, and now let's create a basic template. Now there exist different ways to use JavaScript code within HTML. The first one is by using the script tag, for example. And within the script tag, you can now write JavaScript code. So console.log hello guys, for example. This will output something in the console. But where is the console now? Every single browser has a console. So we can right-click this index.html file, open with live server, and this will open our page within a live server. And now we can open the console by right-clicking the page, inspect, and now here you have this Elements tab, console, sources, network, and so on. So a console is what we're looking for. And within this console, if we're going to reload the page, we can now see, if you take a look right here, hello guys. So by default, every single browser is able to execute JavaScript code. And whatever you write within your index.html will be outputted within the console. The second way would be to include a JavaScript file. So we can, of course, also create an index.js file. Every file that has the ending .js is a JavaScript file. And now we can also just use console.log hello, this is from the file, guys. And now we can also just write JavaScript code in here. And to use this line of JavaScript code within our index.html, we can now also include a script file. So we can say script source, for example, and now we need to define the path to this JavaScript file, which in our case is index.js. If you use this script tag within the body, you usually add it at the end, because you first want to execute or parse all of the HTML code, all of the code like this, and only after you've executed and parsed the entire HTML page, only then you want to execute your scripts. Otherwise, this can result in a lot of bugs. And now if I'm going to reload the page, you can see, hello, this is from the file, guys. So now we've just executed this file right here. The third method, and a method that you will probably not see too often, especially in old JavaScript tutorials, is using the script tag in the head, or linking the file within the head. So script source, and now you can also use index.js. And the reason that a lot of people will not recommend you to do this is because this will not pass the JavaScript file after all of the HTML code, but since it is in the head and the head will be executed before the body, this will be imported first, and only after we've imported and executed the JavaScript file, only then we will pass the HTML code. And of course, this is not optimal because, as I already said, this can result in a lot of bugs, but the modern method to actually do this is to use defer right here, which tells the browser first execute HTML and then execute JavaScript code. And this here is the method that we are going to use throughout this tutorial. So a couple of years ago, you would always add the script at the bottom of your body tag, but nowadays this here is fine and actually a modern way to do it. And now let's again take a look at console.log, which is the first statement that we've learned. This here is just a statement that accesses the console object, the method.log, and that one outputs anything we have within the brackets right here. And you can see we're getting anything within the console. A couple of years ago, to define a variable, you would have used var followed by the variable name, which could be first name, for example. And that one could be Jonas, for example. Now you could just console.log the first name, and this would output Jonas in the console, as you can see. But the modern syntax is to either use let or const. Let defines the variable name, similar to var, but now you can also say first name is going to be equal to puzzle. We're going to save this one, and this will output puzzle in the console. And of course, you have to end every single statement by using a semicolon right after the statement. If I would use const right here, so a constant, you can see that we're getting this uncaught type error, assignment to constant variable. So if you define a variable using let, you can reassign the value later on, so you can change the value. If you're using const instead of let, you cannot reassign the value after your first declaration. And it's a convention if you're going to use const for something like pi, for example, that you use capital letters for the entire variable. And now this here could be 3.14 and so on. And now if I'm going to output pi in the console, you can see that we are getting pi. There exist a lot of different data types within JavaScript, and let's go over the most important primitive types. The first one is going to be a string, so first name, for example, which can be equal to Jonas. And to declare a string, you usually use those quotation marks. So you have starting quotation marks and ending quotation marks, and everything within those quotation marks is considered a string. And you can also use single quotation marks like this, so this is also alright. So Jonas, and let's output our first name, which is Jonas, so this works. And my code editor actually turns those single quotation marks into double quotation marks, but you can also use something like backtick characters. So you can also output Jonas within those backtick characters, and that is the same. So there are a couple of different ways to output strings, but a string is just plain text essentially. There also exists a number, so I can say number is equal to 3, for example. And now we can also output the number, and we're getting 3 in the console. This here is also a number. So in JavaScript, everything is considered a number, even if it's a floating point number. So if you have a comma, it's also a number, an integer. So a whole number is also a number. So all of those are numbers in JavaScript. You also have a Boolean. A Boolean is similar to a light switch. It can either be true or false, so on or off, if you want to think about it like that. So let is cool be equal to true, for example. So you can either be cool or you are probably not cool. So true or false. But is cool can also just be null, so it's essentially nothing. So null is just nothing. And now we're getting null in the console. Or it can also be undefined, so it's not yet defined, but we might define that one later on. To get the type of a variable, we can also use the type of method right here, and let's pass this cool, for example. So we're getting the type undefined. If we're going to use this cool being equal to true, we're getting a Boolean. Let's output our first name. First name is a string, and let's output our number. Our number is a number. So those are the most important primitive types. If we're now having a number and a second number, so number 1, number 2, for example, and number 2 is going to be equal to 4, we can now say that we want to console.log number 1 plus number 2. And this will output 7.14 because 3.14 plus 4 is 7.14. But now if we're going to have let last name be equal to Yuppie, for example, and we're going to use the plus for first name and last name, we will get a different result. And now we're getting Jonas Yuppie. So if we're going to use a number, it's just going to do a normal mathematical operation. If we're going to use strings, so text, it will just concatenate those strings. So that's the difference when using plus for numbers and strings. Now let's take a look at all of the important arithmetic operators. We've already seen the first one, so a plus, so you can just use number 1 and add number 2 by using the plus operator. You can also use the minus operator, which will now subtract number 2 from number 1. You can use multiplication. You can also use division, and you can also use two asterisks to raise one number to the power of the other number. And let's make this pretty simple. So let's have 3 right here, and let's have 2 right here. And now we're saying 3 to the power of 2, which is going to be 9, because 3 times 3 is going to be 9. And now we could also say, let's have a 3 right here, and we'll get 27. We can also use the rest operator, so the modulus, and this divides number 1 by number 2, and then outputs the remainder, so the rest. If we're going to divide 3 by 2, for example, then we will get 1 rest 1. So we will get the remainder, which is 1 in this case. 5 divided by 2 will also be 1, because the remainder is going to be 1 again. If we're going to use 6 and 4 right here, we will get 2, because 6 divided by 4 is 1, remainder 2. Let's now also understand how to increment a number. Imagine we are having a num, for example, so a number, and that number is going to be equal to 0, for example. And now, since I've used let right here, I can increment this number, so I can say num is going to be equal to num plus 1. So our number is going to be equal to the old number plus 1. If I'm now going to console.log our number, we are getting 1 because, of course, we've incremented the number. But instead of using this syntax, I can also use num plus plus, which just means increment the number by 1. We are still getting the same result. I can also use num minus minus, which will decrement the number. And I can also use plus equal 10, for example, if I want to use a different value. And this is equal to num being equal, so this is equal to num being equal to num plus 10. So this right here is just the shortest syntax, which just means increment the old number by 10. You can of course also decrement the old number by 10. You can also multiply the old number by 10 or divide the old number by 10. Let's take a look at escape characters. So maybe we're having this short text, and that one is going to be equal to hello, I'm an NPC, for example. And now we're just going to output this text. And you can see we're getting hello, I'm an NPC. But what if I wanted to create a line break, for example? In that case, I could use /n, and this will now create a line break right here. So this tells JavaScript that this here is not just going to be a normal n, but this is rather going to be a line break. So new line. Now, if you wanted to use an escape character, since the escape character has a special meaning within JavaScript or within text in JavaScript, you also have to escape the escape character. So // means output a normal slash, like so. Now, if you want to use quotation marks, of course, quotation marks also have a special meaning within JavaScript, so I could not just use quotation marks like this, because this would result in a bug. But we can use slash followed by quotation marks, and again, slash followed by quotation marks. And now we're outputting quotation marks, as you can see. So by using a backslash, you can also use quotation marks within JavaScript. But as you can see, once I'm saving this, my code editor, so VS Code, automatically removes the double quotation marks and replaces them with single quotation marks. And the reason for this is that you can also use double quotation marks within single quotation marks. So that's the alternative. Let's take a look at a couple of string functions. So hello guys is going to be the string. And now I want to get the length of the string. So I can use text.length in JavaScript. And this will output the length of the string. And this one is 10. We can use dot to lowercase, and this will turn the string into a lowercase string. So even if I'm going to use hello, for example, all will be output as lowercase. We can also use to uppercase, of course, and this will transform everything to uppercase. We can also trim the text. So now we're not seeing a result. But if I'm just going to insert a couple of white spaces, you can see that we're still getting the same result. And without trim, we would see all of those white spaces. So trim removes all of the white spaces in the beginning and at the end of a string. But let's get rid of the white spaces for now. We can also check if text dot includes, so if the text includes maybe GU. And of course, this needs to be a string. And now we're getting true because, of course, guys includes GU. But if I'm going to say GUS, for example, we're getting false because that is not inside of the string. We can use starts with, and now let's use HE. And of course, this is true. But if I'm going to use HES, this of course is going to be false. So this just checks whether the string is going to start with a certain character sequence. We can also output the index of, and it's going to be -1 if the word or the character sequence is not within the text, and it's going to output the index if the character sequence is within the word. And it's going to output the index of the first appearance of the first letter of the sequence. And in our case, HE is going to be index number 0 because internally Java starts counting from 0. So H has the index 0, E index 1, L index 2, L index 3, O index 4, white space index 5, and so on. So JavaScript does not start at index 1, but it rather starts at index 0. So that's something that you just have to remember. If I'm now going to use O, for example, you will see that this should be index 4 because 0, 1, 2, 3, and 4. You can also replace something, so you can use replace. Let's say we wanted to replace hello with CU. And now we're getting CU, guys. We can also use something like split, and split just splits the text and turns it into an array once we reach a certain character, for example. And this character can, of course, be an O. So every time we have an O right here, we are going to split that one. And you can see we're now getting 3 items because we have 2 O's. So we'll have this right here within an array, we'll have this right here within our array, and we'll have this right here within our array. And oftentimes you will just use a white space. By doing so, you can separate individual words and save them in a list. We did not go over arrays yet, but you'll understand them in a second or in a couple of seconds. But an array is just a list. So right now we are storing this text inside of an array after splitting it into different parts. And that is something that might be pretty useful later on. Let's take a look at some of the most important math functions. So let's delete this right here. And now we can just use a math function. And in JavaScript, we can access the math package by just using math dot. And now you already see a couple of the methods the math object provides. So we can just console.log the output. So let's access math dot, and now we can use .random, for example, to generate a random number. I'm going to save this, and you can see that we're getting 0.55, 0.78, 0.73, 0.94, and so on. So this generates a random number every single time. Now we can also use math.floor, for example. Now we can pass a decimal number, so 4.7 for example, and this will always round the number down. We can also use math.ceil to always round the number up, so even 4.2 will be 5. We can also use math.round to always automatically round down if we are below 4.5 and round up once we are at least 4.5, as you can see. We can also output the absolute value by using math.abs, and if we are having -3, for example, we're getting 3 in the console. So you will only get the value without the sign. You can also use math.pow to raise one number to the power of another number. So let's maybe do 2 and 3. So this will be 2 times 2 times 2, which will be 8. So we're getting 8. We can also get the square root of a number. So let's use 16, for example, and the square root of 16 should be 4. So we're getting 4 in the console. To get the maximum value out of a couple of values, we can use math.max like this. And now we can pass a couple of values right here. So 1, 4, 7, 10, for example. And the maximum value, of course, is 10. If I'm going to use math.min, we're going to get the minimum value, which is in this case 1. And you can also just output pi by using math.pi. And this is not a function, but just a property. And this will output pi in the console. And those ones were the most important math functions in JavaScript. Of course, they exist a lot more, but overall, you will not use math functions that often. So what is an array in JavaScript? An array is basically just a normal list, and you can store values inside of this list. Let's create an array of animals, for example. And now I can create an array by using opening and closing brackets like this. And of course, I can store numbers inside of a list. So 1, 4, 7, 10. But of course, this doesn't make too much sense with our name animals. So I can also store strings inside of this array. So monkey, elephant, and maybe a cheetah. We're going to end the statement by using a semicolon. And now I can just console.log our animals, for example, and we're getting animals in the console right here. Something that is special in JavaScript is that you're not bound to a single value. So I can also mix storing strings, for example, inside of an array. Then you could also store a number right here, and you could also store a boolean, undefined, and so on. So I can store all kind of different values inside of an array in JavaScript. And this here is completely valid. So an array is just a normal list, and you can store all kinds of things inside of this array. You could also create a nested array. So maybe const grades. Now I'm just going to store my grades inside of an array, but maybe I want to have another array inside of this array for every single subject. So maybe the first subject is English, and I had probably a 1, a 2, a 4, a 5, and a 1. Now the second subject is probably something like sports, and I had a 5, or a 6, 5, and a 6. And then I might also have chemistry, and I'll have a 2, a 5, a 3, and a 1. Doesn't matter. So you get the idea. You can create arrays inside of arrays. And this here is a nested array. So how can we now access an item inside of this array? So imagine we wanted to output monkey right here in the console. So we want to access monkey within our code. And we can do so by using the bracket notation. So you define the array name right here, followed by opening and closing brackets. And now you need to insert the index right here. So 0, for example, for monkey. And now you can see we're getting monkey in the console. So why do we have to use 0 for the monkey? And this is pretty simple. JavaScript just starts counting at 0. So the first element in an array has index number 0. The second element has index number 1. The third element has index number 2. And the fourth element has index number 3. So if I now want to access this element true, for example, then this would be index number 2, because 0, 1, 2. And we're getting true in the console. How can I now access an element in an array when this array includes a couple more arrays? And this is pretty simple. First of all, we, for example, want to access the first element. So the first array in this case. So we can say grades of 0. So the first element right here. And now I can access an array again by using the bracket notation. So I can also use the bracket notation for the second array. So again, this here, index number 0, 1, 2, 3, and 4. Now maybe I want to output 4 in the console. So this is element with index 0, 1, 2. And you can see we're getting 4 in the console. Now let's just remove everything and let's create a numbers array. And that one is going to be equal to maybe 2, 3, 4, 5, and 6. And now there exist a couple of array functions that you can use for every single array. So let's console.log the result. And now we can access array functions by using numbers dot. And right here you will see a couple of methods that are available for every single array. And one of them is, for example, the dot length property that will output the length of an array, like so. And you can see the length of this array is 5 because we have 5 elements right here. Now let me only output numbers for now. And you can see we're getting this numbers array. But now we can also manipulate this numbers array. So we can, for example, say numbers dot push, and we can insert an item right here that can be 10, for example. And once I'm going to save this, you can see that our numbers array now has a 10 at the end. So dot push pushes an element to the end of an array. If I want to remove an element from the end, then I can use dot pop, and I have to remove the number right here, and this pops the last element of an array. And now we have 2, 3, 4, and 5. So 6 has been removed. To add an element to the beginning of an array, we can use unshift, and now we can define within the brackets the element that we want to add. and this can be a 1, for example. And unshift adds a number, in our case, to the beginning of an array. But of course, this can also be a string. So now we've added a string to the beginning of this array. To remove an element from the beginning of an array, you can just use shift. So instead of unshift, we are using shift. And now we have removed the 2 from the beginning of this array. We can also only grab a part of the array. So numbers dot slice, for example. And now right here within this method, we have to define a start as an index and an end as an index. So this is index 0, 1. So let's say we want to start at index number 1 and we want to go up to 2, 3, and maybe let's go to 3, like so. And now this method right here returns a new array. So const new array, we can just store it within a new array variable. And now let's console.log the new array, and you can see we're getting 3 and 4. So this gets a part of the old array. We are starting at index number 1, index number 2, and we're going up to index number 3, but excluding index number 3. And now we can also use on our old array, so numbers dot includes, for example, and does this array include the number 2, for example? And we're getting true if this is true, so if our index includes the number 2, and we're getting false if our index does not include the number, so if it, in this case, does not include the number 1. And those are the most important array methods for now, but we'll go over a couple more important ones later on. Let's now understand function. Imagine we wanted to console.log a name, and this name is going to be Jonas for now. And maybe later on we want to console.log another name, and that one is Puzzle. And now every time we want to console.log a name, we have to type out everything. And of course, this is a very simple example, but later on, if you work with JavaScript, you might write a lot of code, and just rewriting the entire code over and over again is not that smart. And in that case, you can define a function. You can create a function by using the function keyword. Now you can use a name. That name is up to you. In our case, this could have the name output name, for example. And now inside of this function, I can just define a console.log statement, for example. And that console.log statement is now just outputting Jonas, for example. So you start a function by using the function keyword, followed by the function name, followed by those brackets. And within those brackets, within those curly brackets, you define what you want to do when this function is being called. Now we can call this function by just using the name of the function followed by brackets right here. And this here is a function definition, and this here is a function call. So first you define a function, and then to really execute the code within the function, you call the function. And you can see now I'm getting Jonas within the console. And now by just duplicating this single line, I can output Jonas a couple of times because I'm calling this function over and over again. And of course, this is very, very simple logic right here. But oftentimes, a function will have a lot of code, and retyping this over and over again is of course tedious. But just hard coding Jonas right here is probably also not the best idea, because now we're just outputting Jonas every single time. But maybe I want to output the name, and if you think about a social media app, maybe you always want to output the user name of a certain user. And in those cases, you can, within those brackets, accept parameters. So maybe the first name, like so. And now this here is similar to a normal variable that stores a value. And now we can just console.log our first name right here. So this right here says we're accepting to get a first name as an argument later on. And once we've gotten this name, we will output this name in the console. And now, of course, for this output name function call, we also have to define a name. And this name can be Jonas for the first one, Puzzle for the second one, Anna for the third one, and maybe Josie for the last one. And now we're getting Jonas, Puzzle, Anna, and Josie right here. And now we could, of course, also say hello plus first name. And this will output hello Jonas, hello Puzzle, hello Anna, and hello Josie. And when defining this right here, this is a parameter. And when passing the actual value, this is what you call an argument. But that's actually just a convention. This doesn't really matter, and it doesn't matter whether you know this or not. But programmers would call this, when defining it, a parameter, and when passing it to the actual function an argument. You can of course also accept a lot of arguments, so I can also say let me get the last name, for example. Now I can also say plus, maybe we want to have a space between those characters, and then I want to output our last name, for example. And the last name could now be whatever you say. And now we're having hello Jonas what, hello puzzle ever, hello Anna you, hello Josie say. Now of course you do not always only want to console.log something within a function. Sometimes you also just want to return something. And in that case, let's create a new function, and maybe we want to calculate the sum of something, maybe the sum of value a and value b. And inside of this function, we want to return the sum. So we can use the return keyword to actually return something. And maybe we want to return a plus b. And now I can create a new variable, for example, that has the name number. And number is going to be equal to our sum of 10 and 20, for example. So now this sum function right here is being called with the arguments 10 and 20. It returns the sum, and we are storing this return sum within our number variable. Now we can console.log our number, for example. And we're getting 30 within the console. Without the return statement, though, we would only add a to b, but we would never return the value, and therefore nothing would happen. So now this is just undefined. So return is really important if you want to return a value. We could also define a default value by just using equal, and this can be 5, for example, and this can be 10, for example. And now, if we do not pass a value to our function, we will use our default value. Otherwise, we will just use the defined value. And since we've currently defined a value, we are just going to use 10 and 20. But otherwise, so let me remove those values, we're just going to use 5 and 10. In JavaScript, there also exists a second way to define a function, and the only difference is essentially the syntax. So you could also create a variable, and that variable could have the name const, and let me say create sum, because we already have sum and we can't use the same name twice. And now this is a variable that is going to be equal. And now right here, we can define something that is called an arrow function. We're going to define an arrow function by using those brackets right here, followed by this arrow. So the arrow function has the name because of this arrow right here, followed by the method body. So the syntax is actually pretty similar. We are defining all of our parameters, again, within those brackets right here. So this is pretty similar. We have the brackets right here after our name, and we have the brackets right here somehow also after our name. In this case, we are defining this as a variable, whereas right here we are defining it as a function. But the result is actually the exact same. And within those brackets, we can also define parameters. So this could be first name, for example. Now we are having this arrow right here. And after this arrow, we are having this method body. And whatever we have inside of this method body, again, will be executed. So we could also just console.log our first name right here. And now we can call this function create sum. Actually, the name does not really make sense. Let me say output name. So let's call output name and pass Jonas as the first name, or as the first and only argument. And now we're outputting Jonas in the console. So you can either use this syntax or you can use this syntax. And both of this is valid and more about preference. In JavaScript, you oftentimes want to do something depending on a condition. So imagine we are having this variable let rain, and it's either raining or it's not raining. And depending on whether it's raining or not, we want to do something. And in order to do that, we can use an if statement. So if rain, now we need to use a comparison operator. So 3 equal signs. And if rain is going to be equal to true, then we want to do whatever we have defined within this body again. In our case, we want to console.log it is raining, for example. And now in the console, we are seeing it is raining. If this is going to be false though, then we're not seeing anything within the console. Else, so if it is not raining, then we want to console.log it is not raining. And now we're getting it is not raining. So you use an if statement by using the if keyword in JavaScript, followed by those brackets. Within those brackets, you define a condition. If this is going to be true, then you're going to execute the code that you've defined within those curly brackets. If this condition does not equal true, then you're going to execute whatever you've defined within the else block that comes after the else keyword. So whatever you have defined right here. But now, of course, you could also have something like age, for example. And age can be equal to 10, for example. Now, for example, we want to check if the person is at least 10. But maybe we also want to check if the person is less than 18 and so on. So we need a couple more conditions in this case. So we can first of all check if age is greater than 18. So if the person is at least 18, and actually we need to use greater or equal to 18. So if the person is at least 18, then we're going to console.log alright. And now we can use else if to create a statement with a second condition. So if age is greater or equal to 10, then we can say console.log you are a little bit too young. And else, so if the person is essentially not even 10 years old, then we can console.log go home kid. Like so. And now we're getting you're a little bit too young because age is equal to 10. If we're going to 5, go home kid. And if we're 19, alright. So we use an if statement followed by the condition, followed by the body, to define what we want to do if this condition becomes true. Now we can also use else if. So if this condition has not been true, then we're going to check whatever we have within else if. If this condition now becomes true, then we're going to output whatever we have within this body right here. And if both of those conditions are not true, then we are going to execute whatever we have within the else block. And if the first condition becomes true, then we're not even going to check for the second and third condition. So in that case, we'll only output the first one. If none of the conditions becomes true, then we're always going to output what we have within the else block. But of course, the else block is not necessary. So I could also just do it like this, for example. And now if I'm going to use 5, I'm not going to output anything, of course. Let's understand the comparison operators. And you've already seen a couple of those ones right here. Now I'm going to console.log. And now let's take a look at the comparison operators. So we can, for example, check whether 18 is going to be equal to 18. And now we will see true in the console because, of course, 18 is equal to 18. So 3 equal signs checks for strict equality. If I'm now going to use 18 within quotation marks, so I'm declaring this as a text, I'm getting false because 18 as a number is not equal to 18 as a text. If I'm now going to remove one of those equal signs though, I will again get true in the console. And the reason for this is that 2 equal signs only checks for equality of the value. So is the value 18 equal to the value 18. And of course, this is true. But if I'm now going to use 3 equal signs, this checks for strict equality. So is the value of 18 equal to the value of 18? And is the data type of a number equal to the data type of a string? And of course, the data type is not equal. And therefore, this right now is going to be false. So 2 equal signs, loose equality, 3 equal signs, strict equality. To check whether a value is greater or equal to another value, you can use greater or equal like this. So is 18 greater or equal to 18? This of course is the case because it's equal to 18. If you only want to check whether 18 is greater than 18, then you use this symbol right here. And of course now it's false because 18 is not greater than 18. You can also check whether 18 is less than 18. Again, this is false because it's not less than 18. You can check whether it's less or equal to 18. This is true because again, it's equal to 18. Now you can also check whether it's not equal to 18. This is false because 18 is equal to 18. Let me turn this into a string. We're again getting false because 18, by using only one equal sign, is equal to 18. But if I'm going to use two equal signs, we're now getting true because now 18 is not strictly equal to 18. So this exclamation mark right here is the not operator. And combined with the two equal signs, it's not equal, or it means not equal. So to sum up, you have equality, strict equality, greater, less than, greater or equal to, less or equal to. And of course, not equal or not equal strict equality. Now let's take a look at logical operators. And we are going to define a variable name that is going to be equal to true. So now it is raining. And let sunny be equal to true as well. So it's raining, but it's sunny at the moment. And now we can check if rain is true. And of course we can say if rain is equal to true. But in JavaScript, you can also just leave this away. And this right here means if rain is true. So if it is raining, then we can console.log it is raining. But now there exist a couple of logical operators that, for example, allow you to check for multiple conditions. So I could say and, which means if it is raining and it is sunny. So if both those conditions are equal to true, then it is raining and it is sunny. And now we're getting it is raining and it is sunny. If sunny is going to be false though, we are not getting anything anymore. And if raining is false, then we're not getting anything anymore as well. So both of those conditions have to be true when concatenating them with an AND symbol. So those two AND symbols. So AND, both of them need to be true. There also exists OR. So if it is raining or it is sunny, then it is raining or it is sunny. And now we're getting it is raining or it is sunny, even though only sunny is true. So when using the OR operator, only one of the conditions has to be true. Let's now take a look at the switch statement. And it is pretty similar to the if statement. And let me show how it works to you. So we can have let grade be equal to A, for example. And now I could, for example, check if grade is going to be equal to A. And if that is the case, then I'm going to console.log grade job, for example. Now I could also say else if grade is equal to B, console.log terrible bro. And now if I'm going to change our grade to a B, we're getting terrible bro. And of course I could use a lot of else if statements and so on to check for all of the possible cases. But under those circumstances, a switch statement might be a little bit shorter. So you start a switch statement by using the switch keyword. Now, instead of those brackets, you define for what kind of variable you're checking for. So grade. Now we are having this method body, and inside of this body, we can now define different cases. So case A, for example. And now for this case, we can say console.log grade. Now we can define a second case, so case B, and right here we can console.log Now we can have a third case, so case C, console.log terrible. And now we can also define a default case, so default like this, console.log I don't know what this was. And right here we need a semicolon. And as you can see now we're getting terrible, I don't know what this was. So we're checking for the first statement, it's not A, so we're not getting grade. Then we're checking for the second statement, it's a B, so we're outputting that. But we're never telling this code to stop executing. And to tell this code to stop executing once we've met a certain condition, we need to use a break statement like this. And this means execute this if case B, for example, is true. So this right here, and then break out. So stop execution. And we need the same for everything else. So if we are having an A, then we want to console.log grade, but then we want to stop the code from executing. So if case A is true, do this, otherwise check for the next case. If case B is true, do this, otherwise check for the next case. And of course, if we're doing this because case B is true, for example, we are then at the end breaking out of this condition or out of this switch statement. And of course, for default, we technically do not really need this, but we can just add this right here. And now we're getting, because we have a B. Let's use A, for example. We're having great, C, terrible, and whatever, I don't know what this was. So in a lot of cases, a switch statement might be the more elegant way to solve a problem. But you could do the exact same by using an if statement. Let me introduce you to the ternary operator. So again, let rain is going to be equal to true. So at the moment it's raining, and now the ternary operator is pretty similar to an if statement. So we can check if it is raining, for example. Now we use this question mark, and we will execute whatever we have after this question mark if it is raining. So if raining is going to be true, so in that case we could console.log rain, and now we have a colon right here, and if raining or if rain is equal to false, then we will execute whatever we define after this colon. So console.log no rain. We're going to save this, and at the moment we're getting rain because rain is equal to true. And if I'm going to say this here is going to be false, then we're getting no rain. So you always define a condition right here at the left. After the question mark, you define what you want to do if this condition becomes true. And after the colon, you define what you want to do if this condition becomes false. And of course, you could also use nested ternary operators, even though I would recommend you an if statement in that case, but let me show you. So if rain is going to be true, and let me also say let sunny be equal to true. So if rain is true, now I can say sunny, and if sunny is true, then I want to console.log rain and sun. Otherwise, I want to console.log rain but no sun. I'm going to save this, and you can see this is how this looks like. And now I'm going to say rain is equal to true and sun is equal to true. So we should get rain and sun. We're getting rain and sun. If rain is true but sunny is false, we're getting rain but no sun. So this is a ternary operator within a ternary operator. But you see, this looks pretty weird, and as I already mentioned, I recommend you to use an if statement under those circumstances. Let's understand scopes. So let's first of all delete this, and let's say I'm having this let rain variable that is equal to true. If I'm now going to write a function, so function say hello, for example, and I'm going to console.log rain, then you can see that in the console, once I'm going to call this function, so say hello, I'm getting true because at the moment it's raining. So even though I'm calling or I'm accessing rain within my function, there does not seem to be a problem. What if I'm going to define let sunny be equal to true within this function right now, and now I'm going to console.log sunny outside of this function? You can see we are getting uncaught reference error. Sunny is not defined. And the reason for this is that a variable is only accessible within the scope of its declaration. So if you declare it right here, so at the highest level of your file, your function will essentially be accessible everywhere. If you define it within this code block, for example, it will only be accessible within this code block. So if I'm going to use an if statement right here, if sunny, for example, console.log sunny, then this function, so let me remove that, then this variable sunny is going to be accessible within this if statement because this if statement is within this block of code. If I'm now going to define a second variable, so let whatever be equal to true, then this variable, whatever, is only accessible within this block of code because it has been defined within this block of code. So console.log whatever is fine. But it's not fine if I'm going to put it right here outside of this block, because now it is defined within this block right here, but it's not accessible within this block anymore. So I hope you get the idea. You can only access a variable within the block where it has been defined. And if I'm now going, let me delete this because this looks pretty weird. If I'm now going to override rain within this function, for example, so rain, let rain, I'm going to define a new variable, be equal to false. You can see that we're getting false in the console because by default, when executing this function first of all looks within the own body, checks whether there exists a variable rain, for example. In our case, there exists a variable rain within the body of this function, so it will use that variable rain. Only if this variable does not exist, only then it's going to take a look at a higher level, so at this variable in that case, and now it will use that variable. So it goes from inside to outside. Now let's take a look at objects. What is an object? An object is pretty similar to the real world. If you have a person, for example, that can be an object. If you have a cube, that can be an object. If you have a fist, that can be an object. So pretty much anything in the real world or also in your imagination can be an object in JavaScript or can be displayed as an object in JavaScript. And similar to an object in the real world, like a person, for example, an object in JavaScript can have properties. So if you think about a person, something like height, speed, weight, looks, and so on. And an object can also do things, so methods in JavaScript. So for example, a person can walk, a person can punch, a person can insult, and a person can code. To create a new object, you again just define a normal variable, so const person, for example, and that one can be equal. And now you define an object by using those curly brackets right here. And within this object, you can now define properties. So something like first name, for example, followed by a colon. And this here is what you call the key within an object. And now you can define the value for this key by saying Jonas, for example. You could also define an age of 24. You can say is cool and set this to false, for example. So now you have a lot of key value pairs within this object that define this individual person. And this variable name can also be Jonas. So now we're having this person Jonas that has a couple of attributes, key value pairs as you name them in JavaScript, but he's not able to do anything yet. Maybe we also want to define something that Jonas can do. And in order to do so, we can, for example, say walk, so the name of the method that we want to define, followed by brackets. Again, we can define parameters within those brackets, followed by those braces. And now we can, for example, console.log walking, like so. And now we can just access all of the properties of Jonas, so of the person Jonas, by using the dot operator. So Jonas.age, for example. And now we could just console.log Jonas.age. And we're getting 24. We can also use Jonas.firstname. And we're getting Jonas in the console. To access a method, we can do the exact same. The only difference is that we're again going to use dot followed by the method name, but we need opening and closing brackets to tell JavaScript that we want to execute this method. And now we're getting walking in the console. Of course, we can also accept a parameter right here. So something like location, for example. And now I'm walking towards plus location. And now I'm going to walk towards Paris. Walking towards Paris. And actually, console.logging Jonas.walk right here is pretty unnecessary because we're console.logging it anyways within our walk method right here. So let's save this. And we're getting walking towards Paris. But we can also return something within this method, for example. So return walking towards plus location. And now we just have to console.log the result that this method returns. So console.log Jonas.walk to Paris. And now he again is walking towards Paris. So of course you can also return something within an object method. You can also return this dot first name plus, now let's add a space, walking towards Paris. And now we are getting Jonas walking towards Paris. what is this right here? This always refers to the object. So it refers to this object. In our case, this refers to the object Jonas. So this dot first name refers to Jonas dot first name. And Jonas dot first name, of course, is Jonas. So this dot age would again refer to the current object. The current object is Jonas and dot age is 24. And this might not make too much sense for you at the moment, because of course in this case, this always refers to Jonas, because this is Jonas, so Jonas is the current object. But when we start to work with classes, this might make a little more sense. There also exists a second method to access properties of an object, so you can use the dot notation, so dot first name for example, but you can also use the bracket notation. So you can use brackets, and now within quotation marks, you can define the key that you want to access within this object. So Jonas of age, for example, and this will output the age of Jonas. Most of the times, you are going to use the dot notation, but under some circumstances, using the bracket notation might be very beneficial, especially when you dynamically access a property. You can also, let's for now just console.log Jonas, for example, and we're getting this object. So this is what an object looks like. We're having first name, age, is cool, walk, so all of those properties and methods. And now we can also add something to this object by using, for example, a dot notation. So Jonas dot biceps size is going to be equal to 1, for example. So he has a pretty small biceps. We're going to save this. And now you can see within this object, we're also having the property bicep size of 1. So this is completely valid. And you can do the exact same by using bracket notation. So biceps size. And this will also add bicep size to our object. So again, to add a property, you can use bracket notation or dot notation. You can also change an existing property, so age, and say age is now equal to 10, for example. And you can see now our age is equal to 10. And of course, you could also use the dot notation for that. So dot age equal to 10 works as well. Now we can also destructure something within an object. So imagine we only wanted to get the first name and the age of Jonas, and we want to use that one later on. Of course, we can say Jonas.age and Jonas.firstname and so on, and always exit it like so. So this works. But there's also a simpler way. So we can destructure the properties from this object by using const. To destructure, you now use opening and closing brackets, similar to an object definition. And now you just define the property names, so the names of the keys that you want to extract. And in our case, we want to get our first name and we want to get our age from this object. This is going to be equal, and now we just need to define the name of the object from which we want to destructure, so extract the properties from, like so. And now we can just use first name like a normal variable. So I can, for example, say first name in the console. This is Jonas, and I can also just use age, and this is 24, because that has been the value that we've previously defined. So this syntax just means whatever I define within those brackets will be extracted from this object that we've defined to the right as a normal variable. So at the moment we're having this object Jonas, and Jonas is a person, but now we could also have a lot of different persons. So we could have another person that has the name Philip, then we could have Josie, whatever. So you get the idea. But now if I would have to copy this entire object and just type out everything once again, and this is, for example, going to be Josie, name Josie, whatever. So we have to update every single value manually. And of course, this isn't really efficient. So we can also create a blueprint for every single person, and then we can create a lot of different objects using this single blueprint. And that is what you call a class. So a class defines the blueprint for every single object. So a class, for example, defines how a human should be structured. So a human should have a name, a human should have an age, a human should have a last name, a human should have a speed, a human should be able to walk, punch, and so on. So a human should have all of those things. But every single human is slightly different. So we use the class to create the basic blueprint and then create an object for every single individual human. So let's just delete all of this. And to create a class, you use the class keyword followed by the name of the class. In our case, it can be human, for example. Now we're just going to use those opening and closing brackets. And within those brackets, we can now define the blueprint. First of all, if you use a class, you usually want to use a constructor. This constructor is just a normal method of this class, so you can use opening and closing brackets and this method body. And usually you accept all of the properties that you want to define within this constructor. So maybe we want to get a first name for a human should have a last name, and a human should have an age. And now within this constructor, we can create a new property by saying this dot followed by the property name. So this can be name, this can be WAP, this can be anything. And this is going to be equal to the parameter that we pass right here. So whatever we pass as a parameter will be the property, so the key WAP of this object that we are going to create by using the constructor. So the constructor will later on construct, so create the object. And let me first of all show it to you. So now we can create a new human. So const Jonas. Jonas is going to be our human. And now we call the constructor by just saying new followed by the name of the class. So new human. And inside of those parentheses, we now have to pass all of the values for our constructor. So as you can see, first name, last name, and age. First name is going to be Jonas. Last name is going to be Whoop. And age is going to be 24, for example. And if I'm now going to console.log Jonas, you can see that we are getting this human that has a key value pair of WAP Jonas. So the key is WAP and the value is Jonas. And by convention, you always just say this here is going to be this.firstName, which is going to be first name. So the first name that we passed as a parameter right here is right here. And this here is going to be the name of the key. So if I'm going to save this, you can see key name is now first name. So this is going to be the name of the key. And that is going to be equal to whatever we passed as an argument right here to the constructor when constructing our new human. And now I could create a second human. So Josie, for example. And now the name is Josie Whip. And she is 27. And now I can also console.log Josie right here. And now we're getting one human that has a first name Jonas and a second human that has a first name Josie. So what is this in this context? This always refers to the human that has been created by using the human constructor. So when creating a human by passing Jonas, Whoop, and 24, this refers to the object that has been created by using this constructor right here. So this, in this case, refers to Jonas. For the second object, so for Josie, this now again refers to the object that has been created by using the constructor. And in this case, this of course refers to Josie. So to the object that has been created by using those values right here. So this always points to the object that has been created by using the constructor for this variable. So within this variable, this points to Josie. So to the human that has been created with the value Josie, Whip 27. And for this variable, this points to the human that has been created by using this human constructor. So by the constructor that has used Jonas, Whoop, and 24, and so on. And now usually when you use the constructor, you also do this dot last name. This is going to be last name, and this dot age, this is going to be age. So you just initialize all of those values by using the constructor. And now we're having this human that has a first name, a last name, an age, and so on. Now we can also define a method within this class. So we can say a human should walk, for example. And now we can just, for example, return this dot first name plus is walking, for example. We're going to save this, and now we can console.log Jonas.walk, and this will output Jonas is walking, and Josie.walk, and this will output Josie is walking. If you now want to get all of the keys of an object, for example, you can, so let's console.log that, you can just use object.keys, and now you have to pass to this method the object of which you want to get the keys. In our case, we want to get the keys of Jonas, for example. And you can see we're getting the keys as an array. So first name, last name, and age. And of course, we can also get the keys of Josie, but the keys are of course the same keys. We can also get the values by using .values. And now we're getting Josie, whip, and 24. So keys will get us all of the keys, so those keys right here, whereas values will return all of the values of that object, so Jonas, whoop 24, or Josie, whip 27. And now, in case we want to get keys and values, we can also use entries. And this returns an array of arrays. So, for the first array, we have first name and Josie, so key, value as an array, last name and whip, so again key and value, and age 27, so key and value. Now let's understand the difference between primitive and complex types. A primitive type is a number, for example. So const number is going to be equal to 10. Now I'm going to say const number 2 is going to be equal to number. And now let me increment number by 10, so number plus equal 10. And now let's console.log number, and let's also console.log number 2, like this. And of course we have to say let number be equal to 10. So now we're getting 20 and 10. So we are taking the value of number 1, so of number, assigning that value to number 2, then incrementing number 1, so number, by 10, and outputting number and number 2. So we're getting two different values because we're only taking the value, storing that value in the second variable, so in number 2, and then assigning the variable number 1, so number. So every time we create a new variable that has a primitive type, we are only taking the value and storing that value inside of the variable. So once we create a new variable, we are going to have a new variable, store that inside of our memory, and assign a value to that variable. So if you create a new variable in JavaScript, you use some storage for this variable. If you create another variable, then you have some more storage, so a new storage cell, for example, and so on. So a new storage cell, a new storage cell, and a new storage cell. So you create a new cell every time you create a new variable, and then you store the value within this cell. Now, an object or an array, for example, is a complex type. So let me show you. Imagine we're now creating const Jonas1, which is going to be equal to Jonas. So Jonas1 is equal to Jonas. I'm now going to console.log Jonas, and I'm also going to console.log Jonas1. At the moment, you can see Jonas1 and Jonas have the exact same values. What is going to happen if I'm now going to say Jonas dot first name is going to be equal to changed first name? I'm going to save, and you can see that Jonas now has a first name of changed first name, but Jonas1 also has a first name of changed first name. And the reason for this is that we're storing a complex type, so an object or an array, in a slightly different way. When we create a new object, we are storing that object somewhere, so storage. And now this object, so Jonas for example, only stores the reference to this location, to this storage location. And whenever Jonas needs to get the data, it's going to take a look at its own pointer, so at what address is the data that it needs. It then sees the location, gets the data from that location, and in our case, console.logs that data. If we're now going to create a copy, so Jonas.1, we only pass the reference to the storage cell to the new object, so to Jonas1. If we are now, of course, updating the data within the storage cell, then we're only updating the data once, so within one single cell. And those objects, so Jonas and Jonas1, still have the same reference to the same cell. And both of those objects will read the data from the exact same cell. So they will both read the updated value. We are not going to create a new storage cell essentially over and over again every time we create a copy. Now let's understand loops, and let's start by using the while loop. We're going to create a number. A number is going to be equal to 0, for example. So let number be equal to 0. Now I create a loop that is going to do something while a certain condition is true. So while number is less or equal to 10, for example, while that is true, I'm just going to console.log our number. At the moment, this condition will always be true because number is always less or equal to 10 because number is 0, and 0 will always be less than 10. But if I'm now, within every single iteration, going to increment our number by 1, for example, so after a couple of iterations, it will not be less or equal to 10 anymore, and therefore this while loop will stop. So you can see we're getting all of the values from 0 to 10. So a while loop starts by using the while keyword. Afterwards, you define a condition. While this condition is going to be true, we are going to execute whatever we've defined within those brackets. We are going to console.log the number and increment the number after every single iteration. So eventually, this condition after a couple of iterations becomes false, and at that point we are going to break out of the loop. So a loop will repeat a certain task over and over again until the condition becomes false. And if this condition from the beginning is going to be false, we're not going to do anything. If I'm going to use a do while loop though, so do whatever we have within those brackets while this condition is true, and let me now execute this again. So you can see we're just outputting our number, even though this condition is not true right here, one single time. So a do while loop works pretty similar to a while loop. The only difference is that the do while loop will run at least once, because we're going to do whatever we have inside of those brackets, and only after that we are checking whether this condition is going to be true or not. If this condition is not true, then we're going to break out of this loop. If the condition is true, then we're going to repeat whatever we defined within this block of code. So while repeats something a certain amount of times, but it can potentially never execute, whereas a do while loop works the same way, but will execute at least once. An alternative to the while loop is the for loop. So you can define a for loop by using the for keyword. Now you define an initial variable, so let I is a pretty common name. So let I be equal to 0. That is going to be our initial value. We are going to execute this loop while I is less or equal to 10, for example. And for every single iteration, we are going to increment I by 1. And now we have those brackets, and we're going to execute whatever we define within those brackets. So console.log I, for example. And you can see we're again outputting I. So right here, the first statement is our initial value for our variable. The variable name is up to us, but I is pretty common. We're going to execute this loop as long as this condition is true, and we're going to do after every single iteration whatever we defined right here. We'll execute whatever we have within this block of code. You can also use a nested loop. So for I being equal to 0, for example, we can also use a nested loop. So we can use a loop inside of a loop. So for, let, and now we need a different variable name. So let j be equal to 0, for example. We're going to execute this as long as j is less or equal to 2, for example. And we're going to increment j by 1 for every single iteration. And now we're just going to console.log I and j, for example. And I'm going to say I is equal to I, like this, and j is equal to j, like this. Let's save this, and you can see we're starting with the value I of 0. J is going to be 0 for the first iteration. We're going to console.log I and j. We're staying within the inner loop until this condition becomes false. So second iteration, I is still 0, j is now 1. Third iteration, I is still 0, j is now 2. At a certain point, this condition within the inner loop becomes false. So we're going to progress to this point. At this point, the first iteration of the outer loop has been finished. So we're going to go to iteration 2 of the outer loop. Now I is going to be 1. We're going to execute the inner loop again until this condition becomes false. So again, for I being equal to 1, we are having j0, j1, j2, and so on. And then again, we are going to finish executing the inner loop, we're going to finish executing the outer loop, and we're going to go to the beginning of the outer loop again. Now I is 2, j is again 0, 1, 2, and so on. So for every single iteration of the outer loop, we're going to loop through the entire inner loop. So over this entire loop right here. Let's also take a look at the for in and for off loop. Imagine we are having an array, so let numbers be equal to a couple of numbers. So maybe 2, 4, 8, and 10. And now we want to loop over those numbers. Under those circumstances, we can use a for off loop. So for const number of numbers. And now we're having this body right here. And we're going to execute the code inside of this body. So console.log number, for example. And now we're seeing the numbers 2, 4, 8, and 10 inside of the console. So this number right here, this variable number, holds one of those numbers for every single iteration. So in the first iteration, number holds the value 2, outputs the number. In the second iteration, number holds the value 4, outputs the number. Third iteration, number holds the number 8. And in the last iteration, number holds the number 10. You can also loop over objects. So imagine we're having this Jonas object right here that is going to be equal to this empty object for now. But we're going to initialize this object with a first name of Jonas and an age of 24. To loop over objects, you have to use the for in loop. So for const key in Jonas console.log key. And we're going to see first name and age. So this variable const key holds one of the keys of this object Jonas for every single iteration. So in the first iteration, key holds the value first name, and in the second iteration, key holds the value age. And if we now wanted to output the value right here, we could of course use bracket notation. So we want to access Jonas of key. And in the first iteration, we are going to access Jonas of first name, so Jonas. In the second iteration, we are going to access Jonas of age, so 24. And we're getting Jonas and 24, so the values. Of course, we could also output the key and the value. So first name is Jonas, age is 24. Let's now understand how to pass strings, for example. We're going to delete all of this, and we're going to define const num1 that is going to be equal to 42, for example, and const num2 that is going to be equal to 20, for example. So we have this number that is a string, so a text at the moment, and we have this number that is a normal number at the moment. Now let's console.log num1 plus num2. And you can see we're getting 4220 because it recognizes 42 as a string, and normal addition does not work on strings. But we can now transform this num1 into a normal integer. So parse int, for example, and this is going to turn num1 into a normal number. And now we're getting 62. If I'm now going to say 42.5, for example, we're still getting 62 because parse int will always return a whole number. So 42.5 will return 42. 42.9 will return 42. If I now want to get this as a decimal number, then I need to use parse float, for example. And this will now return 62.9. So this will keep the decimal places. Now you can also turn this here into a boolean, for example, by using boolean, for example. And now we can pass num1 to this boolean method right here, and we're getting true. And in fact, this here is what you call truth in JavaScript, because the string at the moment has a value. If this is just going to be an empty string, then this is what you call falsy. And you can see we're getting false. So JavaScript interprets an empty string as false, or falsy as you call it in JavaScript. And if we have a normal string, so if we have a little bit of text, so hello, for example, then this is going to be truthy, and you will get true in the console. For a number, so let's turn num2 into a boolean, we're getting true. If we are having 0 right here, then we're getting false. And again, this is truthy and falsy. So that is something that you might want to do from time to time. Let's understand one of the most important methods in JavaScript, which is the map method, which you can use for arrays or which you can use on arrays. We are having this numbers array right here, for example, that has the numbers 1, 3, 5, and 9. Doesn't matter. Any array would do the job. And now we can use numbers.map, and you can use the map method on every single array. The map method accepts a callback function, which means we are going to define a function that will be called for every single element. So it will be called back for every single element. And right here we can now use the arrow function syntax, for example. So we can just define this function right here. And the map method will allow us to get one number for every single iteration. So by default, when using the map method, you can accept the number. And this is pretty similar to a for loop. This number will hold one of the numbers from this array for every single iteration. So iteration 1, this number is going to be 1. Iteration 2, it's going to be 3. Iteration 3, it's going to be 5. And for the last iteration, it's going to be 9. So number will hold one of those numbers for every single iteration. And now we could, for example, just return our number times 2, for example. And now the map method on an array will always return a new array. So const new numbers is going to be equal to numbers.map. And now I can console.log the new numbers. And you can see the new numbers are now 2, 6, 10, and 18. And if I'm going to console.log the old numbers, you will see that the old numbers are still the same numbers. So numbers.map will not manipulate the old array, so the given array right here, but it will instead return a new array and keep the old array as it is. There also exists another method that is pretty important, that is the filter method, that allows you to filter an array. So const filtered numbers, for example, because the filter method on arrays is also going to return a new array. So numbers.filter. Again, for every single iteration, we can get one of the numbers, like so, and we can again pass an arrow function right here. So the syntax is pretty much the exact same, and they work pretty much the exact same. The only difference is that you use map to, for example, map the old number to a new number, whereas filter allows you to essentially remove items from the array, from the given array. And in our case, we could say return the number if our number, so return if number is not equal to 5, for example. So if the number is not going to be equal to 5, then we're going to return the number and store it within our new array. Otherwise, we're not going to return this number. So if it is 5, we're not going to return the number. So our new filtered numbers array will hold all of the numbers except number 5. So let me console.log the filtered numbers for you. And you can see we're getting 1, 3, and 9, but we're not getting the number 5 because we filtered that number. Let's also understand the reduce method for arrays. So numbers.reduce, and for this method we are now again having a callback function, and we can get two values. Let's, for example, say the first value is the sum and the second one is the value. And I will just show it to you and explain it afterwards because I think that is a little bit easier. We are again going to have this callback function, and right here we are going to have a value afterwards. And this value is now going to be our initial value. And sum will be initialized with our initial value. So sum is going to be 0 by default. Value is now going to hold one of those values for every single iteration. So during the first iteration, value will hold the value 1. Second iteration, it will be 3. Third iteration, it will be 5, and last iteration, value will be 9. And of course, we could also use different names, like so. But in this case, since we want to get the sum, I used sum and value. And now I just want to return our sum, which is going to be 0 in the first iteration, plus our value, like so. So first iteration, 0 plus 1. So from this point on, sum is going to store the value 1. Second iteration, value will be 3. So 1 plus 3, it's going to be 4. Sum is going to hold 4 from this point on. Next iteration, 4 plus 5, so 9. Sum is going to hold the value 9. And last iteration, 9 plus 9. and it should be 18. So let me const sum is equal to numbers.reduce, and I'm going to console.log the sum, and we're getting 18 in the console, as you can see. Now let's also understand the rest operator. Imagine we're having a function, sum for example, and the rest operator looks like this. So dot numbers, for example. And for now, I'm just going to console.log the numbers. And now I want to call this function sum, and I'll pass 10, 20, 30, and 40 to this function. And you can see we're getting an array. So the rest operator allows us to use a variable amount of parameters for this function. So we could also use 5, for example. And we're getting all of those arguments that we pass to this function within an array. And now, of course, we could go over this array. So we could just say return numbers dot reduce. We're going to get sum and value. And now we can just say return sum plus value. And we're going to initialize with 0, for example. And this would now return the sum. And now I could just console.log the sum. And we're getting 150. And now I can also say, okay, let's add 50, then we're getting 200, and so on. Now let's understand error handling. Imagine we're just trying to console.log x right here. And this, of course, is a super simple example, but this will also do the job. So we're getting this error, uncaught reference error, x is not defined, because x at the moment is not defined. So every time there's something in your code where an error could occur, you should use a try catch block. So try catch. Within the try block, you define whatever you want to try. So whatever you want to do. So maybe console.log x. And within the catch block, you're getting this error object by JavaScript. And now you can do something with this object. Of course, you do not have to do something with this object, but it's up to you. So you could, for example, console.log the error right here. So we are getting reference error, x is not defined. Or you could also say that did not work. And now we're getting that did not work. And without using a try catch block, every error in JavaScript would crash, so stop the program. But this right here would only catch the error and then keep executing your program. So if you would have something afterwards, it would just go along like hey. And we're getting hey right here, but without the try catch block, you can see our program would just stop right here. So every time an error could occur, always make sure to wrap the code that you want to execute with a try catch block. Now let's also understand JSON. And oftentimes you want to use JSON to transfer data. So for example, data from your front end to a back end. So to a server, for example. And in order to transfer data from the front end to a back end or from the back end to the front end, you oftentimes want to use JSON, so JavaScript Object Notation. And JSON, so JavaScript Object Notation, is very similar to JavaScript objects. We can create a JSON file by saying data dot followed by the extension JSON, so this defines a JSON file. And now you basically define this object right here. And within this object, you can now define your key value pairs. So we can have, for example, a name, and this name can be Jonas. And now I can also define an age, and the age can be 100, 101. I can define a variable is cool, for example, and that one can be true. So this, as you can see, looks very similar to JavaScript. The main difference is really that we have those quotation marks around the keys right here. And you can always define key value pairs. And now you could use this data, so you could send this data, for example, to a server, store the data, for example, over there, or do something with the data over there. And then you might want to get some data again from the server. And then the server will also reply with JSON data, and you would get this JSON data within your front end. Now let's understand a callback. Imagine we are going to create a function. That function, for example, has the name greet. We're going to have those brackets followed by those curly brackets. And now we say, as parameters, we are going to accept a name and we're going to accept another function. And that can be a callback function. And now we are just going to call that callback function within the greet function, and we'll pass this name to our callback function. So a callback function is just a function that will pass to another function that will be called back once the other function is being executed. So now when we execute this greet function as a first argument, we need to pass a name, so Jonas for example, and for the callback function we now need to define a function. So we can use an arrow function right here, or can use the arrow syntax to define a function. And right here, of course, we are accepting a name because we're calling the callback function with a name, so name. And right here we can just console.log the name, for example. Let's save this one, and we're getting Jonas in the console because we're calling this callback function right here with the name Jonas. Now let's understand how to fetch data. From time to time, you might want to work with an API, so application programming interface. So an API usually is something that can give you data, for example. So you send a request to an API, and the API will respond with data, for example. And an example for an easy API is the random users generator API, for example. So random user generator right here. Let's click on this link. And this API will generate a random username for every single API call. And now if you're going to scroll down, you can see that we're having this URL right here. So let's just copy this URL because this is the endpoint of the API. So if we are going to call this URL, the API is going to respond with data if our request is valid. So let's place that right here. And you can see we are getting this result. So the API, when calling this URL, responds with a result that includes gender, name, location, name, city, and so on. So a lot of data that we can use later on. And now, instead of JavaScript, we can also get data from this endpoint by using the fetch method, like this. So like this. If I'm now going to take a look at the console though, you can see that we're not seeing anything. And the reason for this is that a fetch request, of course, takes a little bit of time. So we first have to request something via internet, for example. So the request takes a little bit of time because, of course, we first have to send the request to a server. Then the server has to check whether the request is valid. This takes again a little bit of time. And then the server is going to respond with a little bit of data. And that again takes a little bit of time. So this request is asynchronous, as you call it, because getting the result takes a little bit of time. And if you have a slow internet connection, of course, the time is going to be a little bit longer. And if you have a fast internet connection, it's going to take a little bit shorter. But overall, it will always take a little bit of time. And if something is going to be asynchronous, it usually returns a promise. A promise means I promise you that I will return something in the future though. So it might take a little bit of time. And if you work with a promise, so if you are expecting a promise, then you can use .then, which means once the promise has been resolved, then you can do something. And when fetching data, you will usually get a response from the server. So this response, and now you can use a callback function right here. And you can, for example, console.log the response for now, like this. And now this is what this looks like. And now if you take a look at the response, you can see we're getting this object right here that has a body, okay, status 200. Status 200 means okay. So the request was successful, a status text, and so on. And usually if you want to get the data, the specific data, then you have to use response.json because of course you're going to get the data as JSON object. So by using response.json, you're going to get the data. But again, response.json is going to return another promise. So we're having a promise inside of a promise. So we have to again use .then because once this promise has been resolved, then we're going to get something else. And in this case, we're finally going to get the data. So we can just console.log data. And as you can see, we're getting the results object right here. So the data right here. And of course, this includes a couple of properties. So info, results. So we could, for example, access data. results, because in the end, results is just another object. So data.results, like so. And now we're accessing this array that only has one single element. So we can access data.results of 0. So this object right here, which is the first element inside of this array. And now we're having another object that includes gender, email, ID, location, login, and so on. And now we can, for example, access .email of this object. And now we are seeing, let me save this, the email of this object. And this will fetch a new user on every single reload, as you can see. So Catalina, Asset, Alicia, and so on. So every time something is asynchronous, it will return a promise. And by using .then, you can say what you want to do once the promise is fulfilled. But you can also use the catch block at the end to define what you want to do if there occurs an error. So for example, this URL is invalid, the server is down, and so on. So all of this can of course happen. So for that case, we also need to define a catch block that catches the error. And right here, we are getting this error object, and we can just say that we want to console.log the error, like so. And now let me just use an invalid URL. And now we're getting this error right here, unexpected token, not found is not valid. And I can also just console.log, what are you doing, bro? And now we're getting, what are you doing, bro? And if it is a valid URL, then everything seems to work as expected. But in modern JavaScript, you usually don't use those then and catch chains anymore. Because of course there could be a lot of different promises. So as you already saw, this fetch request returns a promise, then this response.json call returns a promise, and so on. And you already see that this looks pretty weird and is not really clear overall. So the alternative is to use await and async. So async await. So let's create a function, for example, const fetch data that is going to be equal to an arrow function for now. And if you know that the function is going to be asynchronous, so you want to use something like fetch, then you have to declare this function as asynchronous by using the async keyword. And now, since we're working with a database, so we're using fetch, of course there can also occur an error, so we should use a try catch block. And if we're getting an error, we could just say, what are you doing? Like so. And now inside of the try block, we first want to fetch some data. So const res for response is going to be equal. And now when we are doing an asynchronous call to a database, for example, to an API and so on, then we are going to use await to await the result. And we are going to await whatever we have within our fetch request, so within this request right here. So we are going to fetch data. This takes a little bit of time. We're going to await this data, which means wait for the data, and only after we've got the response, only then we want to keep executing our code. Something that is important to understand though is that it will only pause the async function. So if we have something that is not asynchronous right here, like logging for example, then this code will be executed while we are waiting for this response. So we're going to get to this point in the code. We're going to say, let's await the fetch. So we will stop executing this function, this asynchronous function. We're going to keep executing the rest of our code, the code that is not asynchronous, because of course for the rest of the code we do not need to wait. And then JavaScript always keeps track of this request right here. And once we've got the response, it is going to keep executing right here. So this right here, this async await will not block the rest of the code from executing. So the rest of the code that is not asynchronous. So let me show you. I'm going to console.log our res right here. And now I'm also going to fetch data right here. So first of all, we're going to fetch data. But you can see we are first logging this right here. So we're first executing this statement. And then we are logging the response right here. And the reason for this is that we're saying, okay, wait for the response right here. It then executes this console.log statement because that one is not asynchronous. Once it has the response, it's then going to console.log the response. So JavaScript works in a non-blocking way. And now we're going to say const data is going to be equal to res.json console.log data. We are seeing the data right here. This is a promise. So again, we need to await this promise. Now we're seeing this result right here. And again, we can just access data.results, for example, the same way we did it previously. This will be an array. And now we could, for example, access our email. And we're again getting an email right here. And we're getting two different emails because we're doing two different API calls. We're going to use this syntax right here for the first one and this syntax right here, so async await for the second one. And I definitely recommend you to use the modern syntax, so async await in modern JavaScript. Now let me also introduce you to the strict mode. Imagine we wanted to declare a variable x, for example, and x is going to be equal to 10. Now let's console.log x, and we're just outputting x right here. If I'm now going to say use strict right here, you can see that we're getting this uncaught reference error. X is not defined. And the reason for this is that this is not really valid JavaScript syntax. You should usually use either const or let to define a variable. And you can see if I'm going to use let right here, the error is now gone. So use strict just says be super accurate, and every time there's something that is not 100% perfect, please throw an error. So strict mode is just a little bit stricter than the normal mode. Let's also understand temporal literals. So imagine we're having const first name, which is equal to Jonas. Now I want to output this first name in the console, but I want to do it within text. So I want to say hello plus first name. So this right here works. But there's also an easier way, and that is a template literal. So you can use backticks right here. Now you can say hello, and within those backtick characters, you can now access a variable by using a $, followed by opening and closing brackets. And inside of those brackets, you can now use or access a variable. And this results in the same result. And now I can also say hello, first name, you are. And now let's also create an age variable, so const age is going to be equal to 24. You are age years old. Hello Jonas, you are 24 years old. And as you can see, this is a lot easier and a lot more intuitive, in my opinion, than always concatenating strings by using the plus symbol. And now let's also create a second index.js file. And let's say this one has the name helper.js. And inside of this file, we now want to create a helper function that we can later on access within our index.js. So call within our index.js. So for example, const sum is going to be equal to this arrow function right here. We're going to accept two values, a and b, and we're just going to return a plus b. Now we can export this function by using export right here. And now to import this function from helper.js, we can use import brackets right here. Here we need to define the name of this function. The name is sum from ./helper. And now we can console.log sum of 10 and 20, for example. And we're getting uncaught syntax error. Cannot use import statements outside a module. So the reason for this is that this here at the moment is not a module. And in order to turn this into a module, we need to say that the type of this index.js file is module. So this is a file of type module. And now we're getting a new error, so helper not found. And this error occurs because we do not use the .js extension right here. So that is important as well. And now you can see that this right here works. So we have the sum of 10 and 20. We've now covered all of the JavaScript basics, and now we can understand how to use JavaScript for the web. To manipulate an HTML element, for example, we first need to get a reference to this HTML element within JavaScript. And the first way is to use an ID. So we could, for example, create a paragraph, and the paragraph says click me. And now we can use an ID for this paragraph, and this could be the ID text. And now instead of JavaScript, we could, for example, create a variable for const text. The name is up to you. So this could also be text1, text14, but let's use text in our case. And text is going to be equal. And to now select an HTML element within JavaScript, we first have to access our document. So document dot, and now we can use the getElementById method that the document object provides. So document.getElementById, and right in within the brackets, we have to define the ID name as a string. So text for it. And let me also show you the document object. So console.log document. We're going to open the console by right-clicking the page, inspect, and inside of the console, you can see that we're getting this document object. And this document object is just a representation of our entire page. And this is also what you call the DOM, so document object model. The document object model, so DOM, is the representation of our entire page, and we can use the DOM to later get elements by using their ID, by using their class name, and so on. And now I could, for example, console.log the text for you, and you see that we now have the reference to this paragraph. I can also create another paragraph, for example, that says, don't click me, for example, and the second paragraph has an ID of NPC, for example, for whatever reason. And now we can get a reference to this paragraph again by saying const NPC equal to document.getElementById NPC. Now I can also console.log NPC, so the NPC variable, and you can see we're now having the paragraph that has the ID text and the paragraph that has the ID NPC. We could also use a class name. So let's, for example, create a paragraph lorem3. So now we have a paragraph that has a little bit of placeholder text, and we're going to use a class of whatever. And now instead of JavaScript, we can say const whatever going to be equal to document get element by class name. So we can use this method right here. And now we want to pass the class name inside of these brackets as an argument. And the class name was whatever. Now let me also console.log whatever right here. And now we're getting this right here as a collection. And the reason that we're getting this as a collection is because a class is not necessarily unique. I could also have two paragraphs, and both of those paragraphs could have the exact same class. And now you can see that we're getting a collection with two classes. And now I can just access one of those elements by using the brackets right here. So 0 for the first element, 1 for the second element, and so on. I could also use the query selector. So let's say const classes, for example, doesn't really matter. And this is equal to document.query selector, for example. And inside of the brackets of this method, we now have to define a selector. If we want to get an ID, for example, then we have to use a hashtag. So hashtag text, for example, to get the text. So hashtag text to get the text element. And let me remove all of those console.log statements, and let me only console.log classes. And classes now has the paragraph with the ID text. I could also get the ID NPC. And you see we're getting the paragraph that has the ID NPC. Now I can also select classes by using a dot, for example, followed by the class name. Let's, for example, get all of the classes that have the class whatever, or dot whatever. But you can see that we're only getting the first element. So only this element right here. Let me show you. So first, and you can see we're getting this element first, but we're not getting the second element. In order to get more than one element, we have to use query selector all. So this says if there exists more than one element, then get all of them. And let me console.log this again, and we're getting this node list. And you can now just access this node list by using the bracket notation. So we're getting the first paragraph by using index 0. To summarize, you can get an element by using getElementById, get elements by class name, query selector, or query selector all. Now let's delete all of this, and let's understand how to change the text, for example, by using JavaScript. So we're going to delete all of those paragraphs right here. And let's only keep one of those paragraphs, so the one that has the ID text. Now we can select this paragraph by saying const text is going to be equal to document.getElement by ID, and the ID is text. So let's pass that right here. And to now change the text of this paragraph, we can use text.inner HTML, for example. And this could be equal to change text. Let's end this by using a semicolon. And we're having changed text right here. And now I could also use HTML right here. Because of course, by using .inner HTML, I'm saying that I want to set inner HTML. So I can also use HTML. So creating a div is completely valid, for example. And now I could say, hey guys, let me save this one. And now I could just copy this div right here and paste it in there. And now we're having it again and again and so on. So all of this works. But now I could also say inner text, for example. And as you can see, inner text only allows you to add text. It does not accept HTML code. Usually you want to use inner text if possible, because this is a lot safer and less prone to attacks from hackers, for example. Let's now understand how to get attributes of an element. First, let's create an element within our index.html. This could be an anchor tag, for example, and the href attribute just redirects to https://www.google.com. Text could be Google. And now let's try to get this href attribute. So instead of JavaScript, we're going to say const Google going to be equal to document.getElement by ID, and the ID is going to be Google. We don't have this ID yet, so we first need to create for the anchor tag an ID of Google. Let's now imagine that we want to change the text right here to the actual link. So Google.inner text is going to be equal to Google. To get an attribute, we can now use get attribute. And within the brackets of this method, we have to define the attribute. In our case, we want to get the href attribute. And as you can see, we're now seeing the href right here, so the actual link. To set an attribute, we could also use, of course, the name of our element, so Google.setAttribute, for example. And now within the brackets, we first have to define the attribute that we want to specify, so href. And the second one is going to be the actual value. So https://doesn'tmatter.com, for example. And now you can see that right here we are getting doesn'tmatter.com. So by using setAttribute, we can set an attribute, and by using getAttribute, we can get an attribute. Now imagine we wanted to create a new element. So let's delete this and let's create a new div, for example. So div, and this div could have the ID container, for example. And now within this container, we, for example, want to create a new element. So let's first get a reference to this container. So const container going to be equal to document.getElement by ID. The ID is container. And now let's create a new element and then append this new element to this container. So const text going to be equal to document. To create a new element in JavaScript, we use .createElement, and within the brackets, we now have to define the tag name. In our case, the tag name is a P, because it will be a paragraph. And now we could, for example, say text.inner text, for example, going to be equal to I just added this. Now we've created this element, but we never appended this element to our container. So to append this element now, we need to say container.append, followed by the element name that we want to append. In our case, we want to append this text right here. So append our text to the container. So first of all, we are going to get the reference to the container, so to the place where we later on want to add our element. Then we're going to create the actual element. We're going to define the text for the actual element, and then we'll append this element to the container. To now remove this element again, we can use the element name, so text in our case, because that is the variable name right here that we've defined for this element, dot, followed by the remove method. So this is all you have to do to remove an element. You can see the element is now gone. Now let's take a look at styling. So let's keep our text right here for now. And imagine we wanted to style this text right here. The easiest way is to just use text followed by dot style, dot, and right here you can now use a lot of CSS properties. So I could add a color, for example, by just using color. And color can be equal to red. You could also say text.style.background color, for example. And you can see it's not the exact same syntax. It's a slightly different syntax compared to CSS. You don't use a dash if you define the property within JavaScript, but you rather use capital letters for every new word. And if there would be another word, then it would be like the background color could be equal to yellow, for example. And now we have a yellow background and so on. You could also add a class to this element, for example. So we could just say text.classlist.add, for example. Now within those brackets, we can define the name of the class. So this could be the class active, for example. Now within our index.html, let's also link a style shield. So link :CSS. And this links our style.css. We don't have this file yet though, so we need to create a style.css. And right here, let's now create some styles for the .active class. So a background of yellow, for example, and a color of blue or black. So now we've created this .active class within our style sheet or within our CSS file. And in JavaScript, we can now add this class to the element by using ClassList.add. And as you can see, we now have this yellow background right here. We could also add a second class for a container, for example. So container.ClassList.add. And let's add the class container, for example. To style this class, we can now use .container within our style sheet. And for the container, let's use padding of 40 pixels, for example, and a background of Rebecca purple. Now we have this background for the div, so for this container, and some padding. Let's maybe say that this here looks pretty bad. So this container class looks pretty bad. Then I can just use, instead of add, container.ClassList.remove, for example, followed by the class that I want to remove. In our case, I want to remove the container class. You could also use toggle, for example, and toggle will add the class if the class does not yet exist, and it will remove the class if the class already exists. So let me, for example, just remove this line here. So the class container will not exist at this point in time, and now it will add the class container to our container. If the class already exists, or if we've added the class container previously, it will instead remove it, as you can see. Let's also understand events. So let's delete all of this. And inside of our index.html, we can now create a button, for example. This button could say click me and has an ID of btn. Let's start by getting this button within JavaScript. So const btn going to be equal to document get element by ID btn. And now there exist a lot of different events in JavaScript, but the most important one by far, and the one that you'll probably use pretty much all of the time, is the click event. So when a user clicks a button, we can add an event listener by using button.add event listener. This is a method, and the first argument of this method is the actual event. And right here you see a lot of different events. So blur, cancel, can play, all of this exists, but again, the most important one is the click event. And the second argument is now a callback function. So a function that will be called whenever a user clicks on this button. So let's add the callback function. And for now, let's only console.log click. And within the console, let's inspect console. We can now see clicked whenever we click this button. So every time I click this button, we're getting this clicked output in the console. Let's now do something that is a little bit cooler. So let's also add a paragraph, for example, and that one just outputs a number, so 0, for example. And the ID is going to be counter. And now we maybe want to increment this counter every time we click on this button. So we first have to get this counter, const counter equal to document, get element by ID, counter. So now we have the reference to this counter. And on every single button click, we now want to set our counter.inner text to a number. But what exactly is this number? We could first of all define a variable, so let num be equal to 0. So we'll initialize the variable with the value 0. And now let's first of all say num plus plus. So we'll increment number by 1 every time we click on this button. And then we'll set our counter.inner text to our number. Let me save this. Let's click the button. We're getting 1 right here, 2, 3, 4, 5, 6, and so on. Now let's take a look at set interval and set timeout. If we want code to only execute after a certain amount of time, we can use set timeout, for example. As a first argument, we have to define a callback function, a function that will be called once the timeout is over. So console.log 1 second pass, for example. And as a timeout, as the second argument, we maybe want to use 1000 milliseconds, so 1 second. I'm going to save this. Let me inspect console. And once I'm going to save, you can see it takes a second and 1 second pass will be logged in the console. Let me use 4000 milliseconds. And now 4 seconds will pass. And then we'll output 1 second pass in the console because we did not change this. So it should be 4 seconds right here. And we're getting 4 seconds pass. We can now also use set interval, and the structure is pretty much the same. The only difference is that we'll execute this function over and over again whenever the interval has passed, or whenever the time has passed. And now we can console.log 1 second pass again, for example. And as a time, let's now again use 1000 milliseconds, so 1 second. And you can see we're getting 1 second passed again. Let me also show you how to parse JSON data. So from time to time, especially if you work with a server, you will get JSON data. So let's for now pretend const JSON is equal to this object right here. And actually, this is not a normal object. This is just JSON data. And now for the username, for example, we have Jonas, and for the age, we will have 24. So let's imagine that this is a JSON object that we're getting from the server. That includes all of our user data. And now if I wanted to access console.log, so JSON.username, for example, you can see that this will in fact not work because this is at the moment just normal JSON data. To really get this, or to really use JSON, we have to turn this here into an object. And we can do so by using JSON.parse. And now we pass our JSON data to JSON.parse, and this will return a normal JavaScript object. So JSON.parse will transform JSON to JavaScript object. And now we can, of course, store this as a user. So const user is going to be equal to JSON.parse. And we can just console.log user.username, for example. And we're getting Jonas. Could also get user.age. But now there also exists a reverse way. So maybe you have a JavaScript object and you want to transform this JavaScript object to JSON. So you can send this to a server. So user for now is going to be equal to this object that has a username, Jonas, age of maybe 101, and a biceps size of 0. So now let's try to turn this into JSON. So we can also use JSON.stringify, for example. And we want to stringify our user. And let's save this within a JSON user variable. Now we can also console.log our JSON user right here. And you can see that this here is now our JSON. So it looks a little bit different than previously when we had the user as an object. Let's now understand the local storage. So I'm going to delete all of this, and let me also delete the HTML code because at the moment it's kind of distracting. And within our index.js file, so maybe we now want to store the user's IQ within the local storage for whatever reason. So we have this IQ variable, so const IQ going to be equal to 1, for example. Now we can set this IQ variable within the local storage by using local storage dot set item. The key can be pretty much anything, but we just have to remember the key. So IQ could also be something like this, but descriptive would be IQ. And as a second argument to this method, we have to pass our value. And our value is this IQ variable right here. Let's set this one. And now we can see the local storage by right-clicking, inspect. And if you now go to the application tab, you can see this local storage right here. So this local storage tab that includes our page. So HTTP 127.0.0 and so on. So let's click this one. And now you can see that we have our IQ. So we have the key that we've defined right here as a first argument, and we have the actual value that we've defined as a second argument. And the local storage is essentially just some storage that you have within every single browser. And it's pretty useful if you think about a shopping page, for example, because the local storage will persist no matter what. So even if a user leaves your page, for example, and accesses your page later on, the local storage will still be there. So you can store something within the local storage, and later on, once the user revisits your page, you can check whether the user has something within his local storage. And if there is a value stored, for example, then you can do something with that value. So maybe the user adds an item to his cart, then leaves his page, and maybe when he comes back, he wants to keep shopping, but now without the local storage, his item would essentially be gone, and he would have to search again for his item, add it to the cart, and so on. And of course, you would lose a lot of potential customers and a lot of potential sales in this scenario. So it might make sense to store all of those items within the local storage. And once the user revisits your page, you can load all of those items from the local storage and add it to the user's cart again. So to sum up, the local storage is just a permanent storage within the user's browser. So literally every single browser has this local storage. And now we could, for example, get this item by using local storage dot get item, and now we just have to define the key. So this key right here, and this key is the IQ. And now we could, of course, also console.log local storage.get item of IQ. And within the console, we are now having one. So set item to set a key value pair within the local storage, and get item to get an item from the local storage by using the key. Now there also exists the session storage. So let's use session storage. We can also use set item right here. Again, we have to define a key and a value. So up to this point, it's pretty much the same to the local storage. So we could, for example, set the user's power level, and this one is going to be 10, for example. And now if we go to our application tab once again, and in this case to the session storage right below the local storage, let's open this and let's go to our website, so 127.0.0. And now we have this power level of 10, for example. But now let me actually delete this line right here. And let me also delete this line right here. And let me actually quit this page. And let me reopen the page by using the live stub. Again, inspect, application. And if we take a look at the local storage, we'll see that we still have our IQ and our value. If I'm going to go to the session storage though, you can see that our power level is now gone. So the local storage will persist forever, whereas the session storage only persists for one single session. So once the user closes his browser, the session will be deleted. Now let's also take a look at cookies. To set a cookie, we can use document.cookie, and it's going to be equal to a name and a value. So the name comes first. This could be country, for example. And now we want to set our country equal to USA, for example. Let's go to the web page, right-click, inspect, and within our application tab again, we can see all of our cookies. So local storage, session storage, and right here we have our cookie. Let's click on our page again. And right here for our country, you can see we're having USA. So we have the name that we've defined right here. Then we have the equal sign. And after the equal sign, we have the value. And a cookie is more important when you use PHP, but just keep in mind that whenever you send a request to a server, the browser will automatically also send the cookie together with the request. And oftentimes you, for example, send a cookie to the server to authenticate the user. But that's again a little more important when it comes to PHP. I've previously already shown you the document, but let me show you again. So document. And as I already mentioned, this document right here is a representation of our entire HTML document, of our entire page. And of course, we can use the document to access all of the elements by using document.getElement by default. Now there exist a couple similar important objects within JavaScript. Another one is the window object. And the window object, for example, gives us information about the entire window, or the browser window. And we can, for example, get the width by using inner width, like so. And let me just consider log inner width for you, like so. And now if I'm going to reload the page with a different width, you can see that we're now getting 249. I'm going to resize the window and reload, we're now getting 350. We could, of course, also get inner height, like so, and now we're having 455. We can also use the navigator object, so navigator.userAgent, for example, and this will give us information about our browser. So currently, I'm using this browser right here. Now I could also get the location object or use the location object, location.href, for example. And this will return the current URL. And we could, of course, also use location.href to actually update our href. So href or location.href going to be equal to https://www.google.com. And once I'm going to save, we're getting redirected to Google. So I could also use this location object to redirect the user on a button click, for example. And now let me also show you a couple of useful JavaScript functions. The first one is going to be the prompt. So you can use the prompt to prompt the user. So, hey, how are you doing? And now this will prompt the user to enter something into this input field. So I am doing great. Okay. And now we can also store this value. So const feeling going to be equal to prompt, for example. And now I can just console.log the feeling, for example. I am doing good. Thanks. Okay. Let's go to the console. And within the console, we are now having I'm doing good. Thanks. And now you could also, instead of using prompt, use the alert, which is just an alert. So the user is not able to enter something when using the alert. And you could, for example, say, stop it. We're going to save. And now we will have this stop it alert. And you could also use confirm. Are you 18? And right here, we are now getting are you 18? Let's cancel. And of course, you could again store this within a variable. So const is 18, for example. And let's again just console.log is 18. Let's press OK and inspect. And within the console, we are now having, I'm going to reload and I'm going to press cancel. I'm getting false. So I could, for example, use this to check whether the user is 18. If the user is 18, you can let him in. Otherwise, you can show him an error page, for example. And this was JavaScript for Dummies, guys. Woo!